Good day, everybody, and once again we're back together. So this time we'll be looking at electric circuits, aka Ohm's law. So we are going to look at question 8 from the May-June 2025 exam. So if you have not subscribed, please just make sure you are part of this family, right? And we'll continue to give you some great content in maths and science. Right, let's go right into it. They say to us we've got a circuit. In the circuit diagram below, we've got a battery with an EMF of 24 volts, right? So, and an internal resistance of 0.3 ohms. They say light bulb L has got a resistance of 9.5 and R is a resistor of unknown resistance. Ignore the resistance of the emitters and connecting wires. Okay, right. Now they say firstly state Ohm's law in words. Again, ladies and gents, I would implore you to please try and invest in knowing just a bit about your theories, because it actually counts for 10%. That, in my opinion, is actually just low-hanging fruits. Those are marks just waiting to be taken. Right, so they say to us, when both switches S1 and S2 are closed, the reading on ammeter A1 is 0.8, okay? 0.8 amperes. So let's go and check. Where is A1? So A1 is the ammeter reading over here. So they said 0.8 amperes. Now they say to us, calculate the current through light bulb L. Okay. Right. First of all, what I always do, ladies and gents, is that when I look at a circuit, I always want to break it down in terms of, where do I have which current goes where. So total current would go all the way up until this node over here. And what happens? Then our current would divide. So some of the current over here, but it divides even further, right? So you'd have current, let's say, there it is over there, the yellow current. Okay, but let's say also there. All right, let's use another color that we haven't used. Okay, and the blue current over there. Okay, and so what does that mean? It means that both the light bulb as well as the 13 ohm resistor actually divide current. Okay, so it means that those resistors must be in parallel. But also, I realize that in this case, current split even further, right? So what happened? Some of the current went through the 9 ohm resistor, okay? Once you get to this node, now note, in this case, we're going to have the green current over there because the yellow and the blue put together, they give us that green current. But again, the split of the red gave us green and the purple, but with the green and the purple will give us, in this case, the red again, right? So that's the total current. All right, I hope that you can understand that. So every time that we've got, in this case, a current that is dividing, it simply is telling us that we've got a parallel combination, right? So resistor L must be in parallel with the 13 ohm resistor over there, right? So they want us to find out what is the current through the light bulb L. Okay, right, now let's start here. So firstly, we don't know the voltage across light bulb L, but we can find that voltage. Now remember that in parallel, right, voltage is the same. Please remember that in parallel, voltage is the same. So for 8.2.1, okay, so let me do this, 8.2.1. So firstly, I'm going to find the voltage across my parallel resistors. And so which current do I have? I've got the blue current. Okay, let's call this current I1. Let's call this current I2. And let's call this current I3. So in this case, I can find, we know what current I2 is, but also the resistance that it passes through, right? So I'm going to say V which means this voltage over here, I'll come back to that, is going to be I2 multiplied by R, okay, the 13 ohm resistor. So this is going to be 0.8 multiplied by 13, right? So let's find out what that voltage is. 0.8 times 13, that's 10.4 volts. Right. Now I want you to note that means in this case the voltage across the 9 ohm resistor must be 10.4 volts. The voltage across the 13 ohm resistor must be 10.4 volts. The voltage across light bulb L must be 10.4 volts. Meaning the reading on V, because it reads across that 9 ohm resistor, it must also be 10.4 volts. Remember that in parallel, the voltage is the same. So now we can find out what our current I1 is, right? The yellow current. So that means that's going to be V, right? The voltage across our parallel, divided by the resistance of light bulb L. And in this case, we've got 10.4 divided by 9.5. Okay, so we're going to have 10.4 divided by 9.5, and that gives us 1.095. Okay, shall we say that's going to be 1.1? Okay, please, if you don't mind, I'm just going to round that off. Let's make that 1.1 amperes just for the ease of use. Okay, right, so that's going to be our current that passes through light bulb L. All right, now, to be honest with you, they gave this 3 marks. In my opinion, I do think that maybe they could have just given just 1 mark more, but well, it is what it is. So they say to us, let's find out the reading on A2. Now note, what is A2? So we want to find out what is the current, okay? And I want you to note in this case, we had A1 over there, right, which was our blue current. And A2 is the current that passes there. So which one is it? It's the red current, right? So this is the total current that was passing through our battery, right? Now there are several ways in which we could do that. Because we know all our resistors in parallel, we can either find out what the effective resistance in parallel is, right? And find the total current that way. Or we can find out, we already know what I1 is. We can find out what I2 is, right? Or in fact, we already know what I2 is. That's 0.8. We know I1 is 1.1. Okay, so we can find out what I3 is, the voltage that passes through that 9 ohm resistor. Already know that the voltage there is V divided by R. Okay, so that's going to be 10.4 divided by, our resistance in this case is 9 ohms. Okay, so that's 10.4 divided by 9, and that would give us 1.16 amperes. Okay, so that is going to be our current that passes through the 9 ohm resistor. So we can say, well, it means that the total current will be equal to I1 plus I2 plus I3. And so in this case, that's going to be I1, we said it's 1.1, I2, that's 0.8, and I3, which is 1.16. Okay, so let's add those together. Right, I get a total current of 3.06 amperes. Right, so that is the reading on A2. That's the total current in our circuit, right? Okay, as I said, another way that you could have done this is you could have actually found the effective resistance in parallel, and in this case just find out what is or you know that the voltage across it would still be 10.4, and then you can find the total current in that way. Right, and finally, well, not finally, but they say we must get the resistance of resistor R. Okay, now in this case, it's possible for us to find out. Remember, we're given the EMF, right? So I'm going to use the EMF. And the reason is that I want to find out what is the total resistance in the circuit, or what is the external resistance. So if I say EMF, that's I. Okay, so that's 8.2.3 by the way. So EMF is equal to I into R plus small r. Now, if you've watched me, answer these type of questions, I always say, we know EMF, that's that's the EMF of the battery. So we always use the total current here. So this is going to be 3.06, and R is the external resistance. So meaning all your resistors combined, the circuit, we don't know what that is. And if you don't mind, I'm just going to say R external, okay, because I want it to be a little bit more distinguished from R being this resistor over there. Right, plus the internal resistance, which is 0.3, okay, and we can find out what that is. Right, so we can divide by 3.06 on either side. Okay, so I've got 24 divided by 3.06, and I get 7.84, and I will subtract that 0.3 minus 0.3 from the internal resistor, and so I get a value of R external to be equal to 7.54 ohms. Now guys, I want you to note, which means it's all your parallel resistors combined together with R, right? So let's find out what would be our parallel resistors. 1 over Rp, that's 1 over R1 plus 1 over R2 plus 1 over R3. All of those resistors are in parallel, so that would be 1 over 9.5 plus 1 over 13 plus 1 over 9. Okay, now please remember, you are going to also have to invert this, right? So that's going to be 1 over 9.5 plus 1 over 13 plus 1 over 9. Okay, we get all of that. So what do? We need to invert it because we are looking for, so we invert our answer. I get a value of R parallel. This is 3.41 ohms. But remember, what did we say? R external is 7.54, right? So that means, okay, I don't have a lot of space there, but I'm going to do it over there at the bottom. So which means R external would be Rp plus the resistor R, right? So I've got 7.54, which is 3.41 plus resistor R. And what will that give resistor R? So we've got 7.54 minus 3.41, and so that gives us a value for R, which is 4.13 ohms. Right, please confirm if you get the same value, ladies and gents. Right, that is what I was able to get. All right, now let's hop on to the next set of questions. They say switch S2 is now opened. Okay, right. Now, ladies and gents, whenever they give you these kind of questions, the first thing that you must always check is how does that change, right, the circuit? How does that change, the current pathways, and as a result, how does it affect the external resistance of the circuit? So let's check. Where is S? They said S2, right? So I'm going to remove all of these. So the moment we open switch S2, what happens? It means no current is able to flow through this resistor. Okay? So what does that mean? It means we have removed the 13 ohm resistor. Now, ladies and gents, I want you to always remember, once you remove a resistor in parallel, that will increase the resistance of your external circuit. Okay? So once you remove a resistor, you've removed a pathway. So electrons would tend to be congested on the remaining pathways, right? So we're simply saying in this case, right, how will this affect the reading on A2? So what happens, ladies and gents? I is equal to V over R. By removing that resistor, you are increasing the resistance of the circuit, and increasing the resistor will decrease the current. So A2 will decrease. Okay? They said give a reason for the answer. We will say R external has increased, and in this case that will decrease the current in our external circuit. Okay, right. So finally they say, how will the brightness of bulb L be affected? Choose from increase, decrease, or remain the same, and explain the answer. Right, now let's see. So what happens? We've now increased the current. We've rather decreased the current. But now the current will split only two ways. Firstly, it will go there, and the other current will go there. So the current that passes through a light bulb L should be more in this case than what it was before, because the current divided in that case, right? So there should be more current that is passing through light bulb L, and so the brightness, in my opinion, should increase. Okay, right. This is a little bit of a tricky question because there are two things that are happening. You've decreased the total current, but now you've got less pathways in which the current can divide. So ultimately, it will increase that. The current that passes through. Now they said explain the answer. I will say in this case, the removal of resistor, the 13 ohm resistor, will increase the effective resistance, right? So that's what we had said using this equation, right? So firstly, the removal of that resistor will increase R external, right? That will decrease the total current, all right? But in this case, current divides in two ways instead of three, and so it means the total current passing through the light bulb will increase. Okay, so current through L, so IL will increase, and so which means that the brightness, and by the way, how do we gauge for brightness? That's going to be the power. So power is I squared multiplied by R, right? So if current increases, Therefore, it means that the power will increase, and so the brightness will also increase. Okay, right, so that is how we're going to explain that. Okay, you can replay that again so that you can be able to get that explanation. Right, now in this case, the last portion, they say the letters A to F represent quantities in the circuit as shown, right, in the table. All right, they say switch S1 is now opened. Now, the moment we open switch S1, I want you to note, ladies and gents, that it means the current flowing through the circuit is suddenly going to be zero, right? There's no longer any current flowing throughout your circuit, right? Now they say to you, write down the letters of the quantities that will now be equal to zero. Right, voltage across the battery, definitely will still be able to measure voltage across that battery, right, despite the fact that there's no current that is flowing. In this case, the voltage that we'll be able to get will be 24, right, because when there's no current flowing, the voltage in this case across the battery is equal to the EMF, right? So definitely not A. What about B? We've got internal resistance of the battery. Right, now remember that the internal resistance always remains constant, okay? So it is always there. There are internal collisions that are happening inside the battery, so that is not zero, okay? Now they say to us the current through emitter A1, definitely that will be zero. So that's the first one, okay? Remember, there's no longer current flowing in our external circuit. The current through A2, definitely. Okay? And they say the resistance of resistor R. Okay? So that is not true. The resistance is still there. However, remember, it is no longer resisting current, but it still remains a resistor, right? And then the potential difference across the 9 ohm resistor, definitely that would be zero. There's no longer any potential difference because there's no current flowing, and as a result, so our answers will be C, D, as well as F. And ladies and gents, that brings us to the conclusion of this section. Right, electrical circuits out of 23 marks. I think this really was an awesome question. We will see each other again when we answer question 9, which is on electrodynamics. Please, if you have not subscribed, do the right thing, and we'll see each other next time. Sharp, sharp.